I'm sure you've heard of the famous equation E equals mc squared, but to understand where it is applied in nuclear reactions, let's first look at the structure of an atom. In the center of an atom lies its nucleus, a cluster of positively charged protons and neutral neutrons. Around the nucleus, tiny negatively charged particles called electrons swarm about because they are attracted to the protons in the nucleus. How does the nucleus stay together if the positively charged protons repel each other? Great question. This is because of the strong nuclear force, one of the four forces of nature, and by far the strongest. Think of it as a rubber band holding a bunch of repelling magnets together. The amount of energy used to hold an atomic nucleus together is known as its binding energy. When the nucleus is too big to be held together by the strong force, spontaneous nuclear fission takes place. Nuclear fission is the splitting of an atom into two smaller ones. In other words, there are too many magnets, so the rubber band breaks. The strong force is then able to hold the smaller nuclei together. In the case of U-235, the isotope of uranium used in power plants, 3 free neutrons are also fired. These neutrons collide with other uranium atoms, which then split and the cycle continues. This is called a nuclear chain reaction. Another thing to take note of is that the mass of individual particles is greater than the mass of those same particles together in an atomic nucleus. That mass couldn't have just disappeared. Well, it didn't. That mass took the form of the binding energy that is holding the nucleus together. How can mass become energy? This is because mass and energy are equivalent. They can be converted into each other using the mass-energy equivalence formula. Have you figured it out yet? The mass-energy equivalence formula is E equals mc squared. Now you might be wondering how energy is harvested from all of this. Well, when the atom is split, the binding energy that was used to hold the nucleus together is no longer needed, so it is released. Although fission is probably the most useful nuclear reaction, there is another important one: nuclear fusion. Nuclear fusion is the exact opposite of fission. It is the process by which small elements, such as hydrogen, are compelled by the strong force to combine into larger elements such as helium. You can think of this as magnets that are attracted to each other but have bubbles around them. When they're smashed into each other at high speeds, the bubbles pop, allowing them to combine into one large mass. This generates way more energy than fission. Well, then why don't we use fusion in our power plants instead of fission? This is because we don't have the technology yet to build a reactor large and powerful enough to control and sustain such a high energy reaction. However, fusion is still a huge part of our lives. It's used in the sun. The sun constantly combines hydrogen atoms into helium, generating enough energy to keep our entire planet warm. And there you have it. Thanks for watching.